guys, in this video I'm going to run you through a few cheeky little tricks to help us determine whether or not a number is prime. So we're going to be dealing mainly with smallish numbers because this is aimed towards GCSEs and that's really the sort of questions we get asked about. So let's have a little look. So first of all, we know that by the definition of evenness, any even number is going to be a multiple of 2. So any number that ends with 2, 4, 6, 8 or 0 is going to be an even number, meaning that at least 2 is a factor of that number, making it not prime. Now the only exception here is 2 itself, which is the first and smallest prime number. Any other even number though is not prime, so that cancels out almost half of them straight away. 3 gives us quite a cool little trick. So if a number is a multiple of 3, then its digits will also add up to a multiple of 3. So for example, if we go for 18, now we really know that that's not prime already because it's an even number. But just to demonstrate the trick, if we do 1 plus 8, we get 9. Now 9 is a multiple of 3, and that tells us that 3 goes into 18. What about if we do it with something like 73? Well, we do 7 plus 3, and that would give us 10. Now if we weren't sure if 3 goes into 10 or not, we can also add the digits of 10. So 1 plus 0 would just give us 1. Now 3 is not a multiple of 10, and it is also not a multiple of 1. So both of those tell us then that 3 does not go into 73. So that would mean for 73 we'd need to do another test with it, because we know at least 3 doesn't go into it. We can extend this to bigger numbers. Let's go for 123. If we do 1 plus 2 plus 3, then we're going to get 6. Now that's a multiple of 3, and that tells us then that 123 is a multiple of 3. Now that works for any number, no matter how big it is. Even a number that had 1,000 digits, that trick would still work. It would just be a bit of a pain to do. Okay, 5 is also quite useful. Any number that ends in a 5 is telling us that it is a multiple of 5. So for example, 15, 35, 465, 25. Those we know are all multiples of 5 because they end with a 5. So 5's pretty handy. Okay, so let's have a look at an example. So a very common sort of question in a GCSE paper. You'll be given a set of numbers and asked to circle a prime number. So here let's run through all of these and try to determine which of them are prime. So 14 is even, so not a prime, not happening. 35 ends with a 5, also not prime because that tells us it's a multiple of 5. 43, well, it's not even, so 2 isn't a factor, and that counts as out 4, 6, 8, 10, etc. Any even number now we know doesn't go into 43. Let's try the 3 trick, so 4 plus 3. That gives us 7. 7 is not a multiple of 3, so 43 is not a multiple of 3. That cancels out all the numbers that in the 3 times table, so 3, 6, 9, 12, 15. We know none of that lot's going to go into 43. We also know that 5 doesn't go into it. Now it's failed all of our tests, and 43 is in fact a prime number. What about 99? Well, for 99, if we do 9 plus 9, we get 18. 3 does go into 18, so that does tell us that 3 goes into 99. So 99 is not prime. And then finally 79, well, first of all, we know that he's not even, So none of 2, 4, 6, 8, 10, etc. is going to be a factor. 7 plus 9 would give us 16. 16 is not a multiple of 3, so none of the 3 times table goes into 79. So that's out. It doesn't end in a 5, so it's not a multiple of 5. And 79, having failed all of our tests, it is a prime number. So 79 is prime. Now these tests, they don't necessarily tell us definitely that a number is not prime, but between 1 and 100, they do pretty much do the job for us. One exception would be 91. So 91 would fail all of those tests, which would make us think, that must be prime. But 91, sorry, let's move this up. 91, which is almost prime, so it's not even. It doesn't, the digits don't add up to 3, and it doesn't end in a 5, so it would fail all of our tests there, suggesting to us, it could be prime. But 91 is equal to 7 times 13, so 91 is not a prime number. Okay guys, hope that helps. Cheers.